So our next talk is from Sebastian. And Sebastian will talk about Infiltrator.jl. And as all of you know, to write a high-quality code, you need a high-quality debugger, basically to transform a low-quality code to high-quality code. So this talk is about interactive debugging in Julia. So Sebastian, stage is yours.
Oh, yep, works. All right, hey everyone. My name is Sebastian. I'll talk about Infiltrator.jl. It's got a weird name, but essentially it's a no-overhead debugger for Julia without any additional dependencies. Well, when I say no overhead, that might be overpromising a little bit. It is a low runtime overhead debugger for Julia, but we'll get to that in a little bit. Why does this package exist? Well, we didn't have anything like it in 2019 when I wrote the package, and at that JuliaCon, Tim Holy, Christopher Carlson, and I had a talk about Debugger.jl, which included some talk about downsides and limitations it has, and that basically spawned the idea for Infiltrator.jl. Generally, I think we should take a look at what alternatives there are for debugging in Julia. Like the most basic thing is println-debugging, or using logging macros. It doesn't have a lot of runtime overhead, right? It just prints to standard out, standard error, whatever. Not much going on there. But on the other hand, it's not particularly flexible, so you need to know what you want to look at before executing your code, right? It needs to happen at code write time. And the output can end up being pretty messy if a lot of function calls happen. So another thing we have is Debugger.jl, JuliaInterpreter.jl, which is nice when it's fast enough, but also carries a fairly big overhead for each function call that gets interpreted, which needs to happen for breakpoints to work at all. So in some cases, it's just way too slow to be tractable at all. You'd wait a couple of minutes for code to execute that, when compiled, would only take a few microseconds, if at that, just because Julia is optimizing so much away, or inlining function calls and so on. What else is there? Well, GDB, RR, those exist. They're powerful. Do carry some limitations. One is that it's often hard to map back to a Julia expression from wherever you ended up in the C, in whatever C frame you ended up in. And yeah, it's also user-unfriendly. I don't know how to use it properly. Many of you probably also don't know how to use it properly to debug Julia code. It's nice to look at Julia internals, but for high-level Julia code, it gets difficult. All right, let's talk about Infiltrator.jl. It has a fairly simple API. There are two main macros, at exfiltrate and at infiltrate. Exfiltrate, well, it exfiltrates local variables from a scope into a safe house, which essentially is just a module. And at infiltrate, smuggles a REPL into a local scope, so you have interactive code execution there, and have access to every binding in the local scope, as well as the module scope it lives in. All right, let's look at a quick example for code exfiltration. So I've got this super simple function here that has a bunch of local bindings, x, y, z, and zz. If I call exfiltrate in there, then our safe house at the bottom ends up with all of those bindings. So that's like the most basic use case for that. I think exfiltration has its place, but its power pales in comparison to infiltration, for which I've got the exact same example, except that now instead of assigning the local bindings into a module, we get dropped into this infil REPL. In there, we have a bunch of primitives defined, like at trace, which just prints the current stack trace, and a few others. And as I said before, you get full code execution and access to local and global bindings. So I can compute what 2 times z ends up being in that, or at that point of execution. And yeah, it's 6. Now, you might wonder how to use Infiltrator when you're developing packages or don't just have a function in the REPL that you want to inspect. Because it requires source code modification, I'd suggest using revise for that, which means you have to dev the package, find the function you want to set the breakpoint in, drop in main.add-infiltrate in there, go back to your REPL, and run the code. Revise will take care of the rest. You can also use inline evaluation in VS Code if you want to do that, or use the functional form of add-infiltrate, which is just infiltrate the function without the add, which is precompiled safe if you guard it properly. But I would not suggest doing that because A, it ends up in your code, and you might accidentally end up committing it because your tests might still work if you guard it properly. And B, it's also much more annoying to use. All right. I've got a quick demo here. There's this package, TSD parser, that powers basically most of the parsing for the VS Code extension. And recently, Julia got this public keyword. We had to talk about that yesterday. The initial implementation of that was slightly buggy. It would it would not handle the conditional parsing correctly in some cases, so this would end up being parsed as a keyword as well. Instead, it should just be a function call. So I've dropped this main.add-infiltrate in the function definition, where I know that public is being handled, and I can query what infiltrator can do for me. As I said before, it has a bunch of primitives defined, just as macros, or macro-like objects that are special cased in the REPL. You can, for example, toggle an infiltration point on and off, or make it conditional if you want to. You can continue to the next infiltration point, or just exit this infiltration session completely. Anyways, I'm interested in this parse state object. And in this case, that's going back here to the code I'm actually parsing. I'm here. This is working fine. I had Control-D to move on to the next breakpoint. This REPL fully supports tab completion. So if I want to inspect the next token here, I see that it's a left parenthesis, which I don't care about. I am much more interested in some other objects here, namely the next white space. It's empty. In this case, that serves as a pretty good indication that I shouldn't parse this as a keyword. So I can just add a not is empty white space here into my code, and well, I'll just do it here. I'll exit the session. Yeah, if I run my code again, hopefully this parses correctly. You also see here the overhead. It's mostly compilation overhead. And there's not much we can do about that. But the runtime overhead should be fairly minimal. Anyways, I'm running out of time, so I'll switch back to my slides. When it comes to the implementation of this, it's pretty basic. It uses base.add locals, which got introduced in Julia 1.1 or something. So it should be fairly widely compatible with many Julia versions. And then there's a bunch of eval magic into anonymous modules. And there's a whole lot of REPL boilerplate. But yeah, it's not rocket science. So yeah, in summary, Infiltrator.jl is an interactive Printline debugger. Feel free to add it to your global environment. Put it into your startup.jl. The loading time is minimal. All right. Any questions?
Thanks. Do we have a question from the audience? Oh, yes, we have a question.
When working on the packages, should Infiltrator be part of, say, package dependency? And how do you remove it, or what workload how should you use?
Right, so I would suggest putting Infiltrator into your global environment and doing your package development in a local environment. These two get stacked on top of each other, so you still have access to the Infiltrator bindings in that local environment. I would never suggest adding Infiltrator to a package project.toml.
Yeah, OK.
Thanks. So thanks, Sebastian. Extra round of applause.
Thank you.